Hello, my dear students. Today we shall learn about inelastic collision and its numericals. तो सबसे पहले हम लोग जानेंगे कि इनइलास्टिक कॉलिशन होता क्या है और इलास्टिक कॉलिशन के साथ इसका डिफरेंस क्या है। तो इलास्टिक कॉलिशन में क्या होता है कि in elastic collisions the two quantities will be conserved. One is linear momentum, and kinetic energy. These two terms will be conserved in elastic collisions, but in practical life there is no example of elastic collisions. वास्तव जिंदगी में इसका कोई उपयोग नहीं है. The all types of collisions is perfectly inelastic collisions. There are three types of collisions. One is elastic collisions, in which the linear momentum and kinetic energy conserved, and one is perfectly inelastic collisions, which is perfectly inelastic collisions in which the linear momentum is conserved but kinetic energy is not conserved. Linear momentum conserved but kinetic energy not conserved. Why? Why kinetic energy not conserved? Because there is a transformation of mechanical energy into potential energy, into deformed potential energy. When a ball strikes with another ball, at the point of contact the two balls deformed. Here kinetic energy is transferred into deformed potential energy. So the kinetic energy is not conserved in inelastic collisions. When two particles collide each other and they stick with each other and go with a single object with same velocity v is called inelastic collision. Let us do it briefly. Let us consider two balls placed on ground. One is ball M, one is A ball and other is ball B. The mass of ball A is m1 and it goes with velocity v1. The other ball, that is ball B, have mass m2 and is go with velocity v2. After certain time t, ball B collides with ball m1. Ball B collides with ball A, that is m2 collides with m1. And after collisions, the ball of mass m1 goes with velocity v1 dash and ball of mass m2 goes with velocity v2 dash. But in this case the two balls stick with each other, that is the two balls will combine with each other and they go as a single object with same velocity v. Therefore the total mass here is m1 plus m2. So from the conservations of linear momentum we can get m1 v1 plus m2 v2 is equal to m1 plus m2 into v. V is the velocity of the two balls after collision. So we can get velocity v equal to m1 v1 plus m2 v2 divided by m1 plus m2. This is the velocity of ball after collision. This is the example of perfectly inelastic collisions. Suppose two ball of clay will be collide and stuck with single object. A car goes opposite to a truck and it collides and they stuck with each other. All types of collisions, example of collision is called inelastic collisions. The same result can be evaluated from the expressions of elastic collisions, as we know earlier. In the earlier case, we can know that for elastic collisions or we can say in general, the velocity after collision is v1 dash and velocity after collision of mass m2 is v2 dash. The velocity after collision of ball of mass m1 is v1 dash and mass m2 equal to v2 dash. What is the expression of v1 and v2 in the terms of v1 v2? v1 dash equal to, I can write it in general form, not inelastic collisions. We can derive the result of, we can get now m1 v1 plus m2 v2 by m1 plus m2 from these equations. Please see it. हम जानते हैं कि अगर दो बॉल v1 और v2 वेलोसिटी से जाते हैं और वो कोलाइड करते हैं, तो उसका जो वेलोसिटी आफ्टर कॉलिशन होता है वो है v1 डैश एंड v2 डैश. व्हाट वी कैन गेट v1 डैश m1 माइनस e m2 डिवाइडेड बाय m1 प्लस m2 इंटू v1 प्लस m2 प्लस e m2 by m1 plus m2 into v2. This is the velocity of ball A which has mass m1 after collision. In general, this is in general, because we can take E, not the value of E. For elastic collisions, that is perfectly elastic collision is 1, and for perfectly inelastic collision is 0, and partial inelastic collision is between 0 and 1. But here we can say in general form. So in general form, v1 dash equal to m1 minus em2 by m1 plus m2 into v1. v1 is the velocity of mass m1 before collision, and v2 is the velocity of mass m2 before collision. And what is v2 dash? m2 minus em1 divided by m1 plus m2 into v2 plus m1 plus em1 by m1 plus m2 into v1. Now for elastic collisions, E equal to 1, equal to 1. If we put E equal to 1, we can get the velocity of v1 dash and v2 dash in terms of v1 and v2. The result is derived in my earlier class. Please see this in my I button. When the video is playing in I button, you can see the full video of elastic collision, but here we can only consider inelastic collision. So for inelastic collision, E equal to 0. If we put E equal to 0 in this equation, that is v1 dash, what we can get? v1 dash equal to E equal to 0, that is only m1 v1 by m1 plus m2, m1 v1 by m1 plus m2 plus E equal to 0, that is m2 v2 by m1 plus m2. If we, that is m1 v1 by m1 plus m2 plus m2 v2 by m1 plus m2. If we add this, then we can get m1 v1 plus m2 v2 divided by m1 plus m2. The same result we obtained, or we write it before. And again, what is v2 dash? v2 dash is also, if we put 0 in this equation, we can also get v2 dash equal to m1 v1 plus m2 v2 divided by m1 plus m2. That is the same velocity equal to v. In this way, we can see that for inelastic collisions, the two particle system is considered as a single system with the same velocity v. Now understand, I hope you can अंडरस्टैंड, अच्छे से समझ आ गया होगा आप लोगों को। तो अब मैं कुछ न्यूमेरिकल प्रॉब्लम्स दिखाते हूँ जिसके थ्रू आप लोग का आइडिया क्लियर हो जाएगा। लेट अस कंसीडर विथ एन एग्जाम्पल। प्लीज राइट डाउन इन योर कॉपी। Let us now start with an example. Two balls of equal mass, one is at rest and other is coming with velocity v, collides inelastically, and the final kinetic energy, that is Kf, equal to 3/4 of initial kinetic energy. This is the condition given. Then we can find out the coefficient of restitution. The problem is two balls of equal mass, one is coming with velocity v and other is at rest. They collide inelastically, and the final kinetic energy of the system is equal to 3/4 of initial kinetic energy. Then find out the coefficient of restitution. This is the example of inelastic collision. Now, how can we solve it? इसके लिए हमें एक चीज़ याद रखनी होगी। When in general case, when m1 mass have velocity v1 and m2 mass has velocity v2 comes to m1 when v1 equal to 0 and m1 equal to m2 equal to m will be given, and the velocity of v1, that is velocity of m1 equal to 0, then value of v1 and v2 dash will be, that is velocity after collision, v1 dash equal to 1 plus e by 2 into v2 and v2 dash equal to 1 minus e by 2 into v2. This is the basic formula. In general, when the two equal mass are, when the mass of the ball are equal and the mass of the m1, the velocity of m1 mass v1 equal to 0 and the velocity of m2 mass is v2 before collision, then after collision equations, that is v1 dash v2 dash can be given as 1 plus e by 2 into v2 and v2 dash equal to 1 minus e by 2 into v2. You can write it as notes, important notes. So, we can come with this example. Here, as this is an inelastic collision, so we can get v1 dash, that is velocity after collision, is 1 plus e by 2 into, here v2 equal to v, we can say that coming with velocity v, and v2 dash equal to 1 minus e by 2 into v. समझ में आया? v1 dash after collision of first ball, v2 dash after collision velocity of second ball. V is the velocity of first ball and initially the first ball is at rest. So, the velocity, if the velocity after collision of this first ball is v and is v2 dash and this velocity of other ball is v1 dash, then v1 dash equal to 1 plus e by 2 into v, v2 dash equal to 1 minus e by 2 into v. Now, we can given condition Kf is equal to 3/4 of K initial. Now, 3/4 of initial kinetic energy is, what is initial kinetic energy? Half into m into v square equal to 3/4 of initial kinetic energy equal to final kinetic energy. Final kinetic energy is half m v1 dash square plus half m v2 dash square. Half m v1 dash square plus half m v2 dash square. If we put the value of v1 dash and v2 dash, now we can put the value of v1 dash and v2 dash. What we can get? That is 3/4 3/4 half m v square. M is cancelled on either side. There is 3/4 into half v square equal to half v1 dash square, that is 1 plus e by 2 square into v square plus half v2 dash square 1 minus e by 2 square into v square. Now half v square term is cancelled on either side, so we can get 3/4 equal to 1 plus e square by 4, as e coming out from the square, 1 minus e square by 4. So we can cancel 4 on either side, that is 3 equal to 1 plus e square plus 1 minus e square. 1 plus e square 1 minus e square equal to 3. Now a plus b square plus a minus b square, what is the value? That is 2a square plus b square equal to a plus b square plus a minus b square. 2 a square plus b square, that is 2 into a square plus b square. A square means 1 square, that is 1 plus e square. That is, we can get 3/2 equal to 1 plus e square. That is e square equal to 3/2 minus 1, that is half. 3/2 minus 1 equal to half. Therefore, we can get e equal to root under half, that is 1 by root. 1 by root. In this way, we can find out the coefficient of restitution. I hope you will solve it. This is the example of purely inelastic collisions. So, very basic, if we summarize the total problem, if we summarize the total theory, so what we can get? Number 1, for elastic collision, V1 dash equal to M1 minus M2 by M1 plus M2 into into V1 plus twice M2 V2 by M1 plus M2, and V2 dash is equal to M2 minus M1 by M1 plus M2 into V2, plus 2 M1 by M1 plus M2 into V1 for elastic collisions, where V1 dash V2 dash are velocity after collision of mass m1 and m2 respectively. This is the velocity of m1 particle mass ball, and this is the velocity of m2 mass. For inelastic collisions, there is a not v1 dash v2 dash are different, we can get a single velocity v, that is m1 v1 plus m2 v2 divided by m1 plus m2. And number 3, if m1 equal to m2 equal to m and v1 equal to 0, v2 equal to v, v2 equal to v, then we can get v1 dash equal to 1 plus e by 2 into v, and v2 dash is equal to 1 minus e by 2 into v. This is the basic formula of elastic collisions. You can write down in your notebook and do numericals. So, we can know the basic equations of inelastic collisions. I hope you will easily solve the all numericals in your class. A homework is given by me to you for you. Please write down the homework. I will solve it in the next class. There are two mass A and B, and a spring is connected with A with force constant K equal to 200 Newton per meter. The block B is come to A with a velocity 2 meter per second, and the initial velocity of E is 0. Then they collide inelastically. There is inelastic collisions occur. When inelastic collisions occur, then what will be the result? This is A and this is B. Then the spring is compressed. Spring is compressed when they are collided. Now, the question is, find the maximum compression of spring. फिर से मैं बोल देता हूँ, दोहराता हूँ फिर से. दो मास है, एक है A, एक मास है ब्लॉक A and other is B. A is at rest and a spring is attached with A. The block B comes to A with velocity 2 meter per second. After collision, they make an inelastic collision. After collision, the spring is compressed. The force constant of spring is given, K is equal to 200 Newton per meter. Find out maximum compression of the spring using the relation of inelastic collisions. I can tell you the answer, 10 semi. Maximum compression x semi equal to 10 semi. This is the homework for you. Do it yourself. Do not talk to your teacher or do not take any help. I can solve it in my later class with an amazing next class with some others topic. And तब तक के लिए धन्यवाद, शुक्रिया, थैंक यू.